Okay, so I'm going to go ahead and start now. I had a little interruption there. So what I want to do was talk about the Blockchain Training Alliance exam, the architect one specifically. However, if you have any questions on the other exams, I'm more than familiar with them, and I do teach those as well. Now, this is a very exciting time in blockchain because of the fact that it is being adopted. It is a little bit slower than perhaps what we've seen in other technologies, and I think it's really important to appreciate, for example, use cases of a blockchain. And on the exam, I just want to point out a few things. I'm going to share my screen here in a few minutes, but I just want to point out that contrary to what you're reading or hearing, blockchain is actually being adopted pretty rapidly, albeit in a smaller, more what I would call simplistic proof of concept, or at least in a deployment that may not be production ready, but it is being deployed. It is actually being utilized. There's plenty of great examples online. Now, on the exam, you're not going to be tested per se on specific examples or anything like that, but you will need to know what exactly are use cases for blockchain. So let me go ahead. I want to share my screen here, and I want to just talk about the objectives, and I want to give you some tips on that. And then I'm going to go into some resources that you'll need to look at for studying for the exam. Now, let me go ahead and just pull up the cert. And let me share my screen. Now, I took this exam about a year ago, right when it first came out. And I was one of the first folks to write about the exam and actually give the exam significantly more exposure just because of my connections and notoriety in the industry as well. But what I'm trying to get at here is I believe in blockchain, and I'm not trying to, waste my time or anyone else's time, because again, it is important to know where it is now, but where it's going to go. Now, on the exam, we want to know some use cases and some areas around that. Now, I'm going to go ahead and share my screen. Give me a second for it to propagate. And let me bring up my browser. Okay, so now you should be able to see the screen, and I'm going to go ahead and move that over here so it's out of the way. And I'm over here at the BTA website. What I want to do is just take a quick step through the objectives, and I want to talk about a few of these objectives. I think it's pretty critical before you take any exam to understand what you're going to be tested on. Now, I had initially started a few live streams on this on YouTube, but I had so many technical issues that I just decided it was easier to use Zoom, and it also made it easier for me to avoid copyright strikes on YouTube. So one of the challenges with YouTube is they have these bots that just automatically ping you if you have a kitty cat photo or anything silly like that, which even, isn't even trademarked or anything. Even if it's yours, they'll ping you. So that's one of the challenges with the YouTube. But I want to go over here, and I want to talk about a couple areas, and then let's follow up on two or three of these tonight. And then the next week we'll follow up on 2 or 3 more, and then go through, probably about 6 or 7 sessions and see how the performance of this is going, and we'll take it from there. So tonight, we're going to focus on the objectives. So we need to talk about algorithms, proof of work, proof of stake, and other proof systems as well. Now, what this means is like proof of work being a consensus algorithm that's typically utilized in Bitcoin or Ethereum at this point in time. Now, Ethereum will be going to a proof of stake consensus here shortly, assuming that there isn't another surprise down the road, but we'll see where that goes. Now, another form of proof of stake would be, for example, Dash. Dash uses a form of proof of stake as well. Now, what I want to do is close my email here. Sorry about that. Now, what I want to do is cover the objectives, and then we're going to dive into 2 or 3 sections a little bit more. So cryptocurrency, we need to know, for example, why do we want to deploy cryptocurrency? Now, if for an enterprise blockchain, we really don't need to have a cryptocurrency for our nodes or for our services in the enterprise. Well, why is that? Because of the fact that the enterprise is permissioned. We generally don't need to have any kind of way to pay for using, for example, in Ethereum, the Ethereum virtual machine. To use Ethereum, you have to purchase what? Ether. And what I'm talking about now is testable objectives that you're going to see on the exam. So for example, when it comes to cryptocurrency, know the use case over why it is used. For example, you need to have some way to pay for resource utilization in a blockchain, and that's true in permissionless. However, in permissioned, having a requirement for cryptocurrency is generally not a requirement. Now, can you extend out to an off-chain? Absolutely. Quorum is a good example of an off-chain approach that could be used. Understand what the difference is between public, private, and permission blockchains. Now, generally, when we look at a blockchain, we want to realize what's public, what's private, and what is permissioned. On the exam, you'll be tested on identifying what is a public blockchain, a private blockchain, and permissioned. So, a public blockchain is what? Open to the public. In other words, anyone can join. There's no membership requirements. Now, private is essentially where you're performing a transaction, but that doesn't mean that it's a permission blockchain per se. So it could be, for example, that you're performing an off-chain and it's a point-to-point connection, sort of like a tunnel. Now, permission blockchains are going to be a little different, where you're going to deploy Hyperledger or perhaps deploy R3 Corda. Now, when it comes to understanding the difference, is very simple. Just realize, is it permissioned or is it not? Do you need to have membership or do you not? And that should help alleviate some of the challenges there. As far as blocks being written in the blockchain, we do want to understand how blocks are written in the blockchain. For example, what I like to do is I'm going to talk about hashing here in a few minutes, and I'll bring you over to a website that you'll want to look at to help understand how hashing works. Now, when it comes to cryptography as well, we'll talk about that in the hashing demo a little bit more. And then we'll talk about use cases for public blockchains. Well, why do we want to have a public blockchain? Well, a public blockchain is going to serve several purposes. It's going to essentially alleviate the requirement for someone to deploy a blockchain on their own. So it's essentially a way to crowd share resources. Another reason for a public blockchain is that the application is being deployed that perhaps need to have resources that are distributed. And those resources that are distributed, of course, need to have miners, and you need to, of course, pay those miners for those services. But basically, a public blockchain can provide, for example, transparency. It can provide visibility, can also provide some other benefits as well. However, we know that, for example, a public blockchain is not going to provide privacy. Generally, public blockchains do not perform as well as a private or permission blockchain because the membership is so extended and distributed as well. For example, in a Hyperledger deployment, you could deploy 8 nodes and they could be in the same data center. Now, I don't generally call 8 nodes in a data center being distributed, but again, it could be considered that. Once again, however you consider distributed is up to you. But generally, when we look at distribution of nodes, they're going to be geographically distributed. Now, what about private or permissioned? Well, I like to consider permission blockchains really the gold standard when it comes to enterprises. Very rarely do you see an enterprise deploy a public blockchain or even participate in it. And why would that be? Why would we not want to have a permissioned blockchain? Actually, I should say, why would we not have a permissionless blockchain for an enterprise? Well, because we need to have membership. We need to control who is able to view our data. There may be other reasons too, right? Like compliance, such as performance. If we go permissionless, the nodes are distributed over a wide geographic area. For example, in the case of Bitcoin and Ethereum, there's well over 100 countries that have nodes deployed for those blockchains. Whereas with permission blockchains, they're deployed by an enterprise or a consortium as well, like Corda or Hyperledger. So members may share in the resources as well. Now, what do you need to launch your own blockchain? Well, that's a really good question. It really depends. It depends on what you have and what you don't have, but also what you want to accomplish. But basically, you're going to need to have, of course, some location to deploy your nodes. You need to have resources, expertise. You need to deploy smart contracts, and therefore you need developers to be able to attend to that. But with that said, there's a lot more. We'll talk about that. Now, when it comes to deploying your blockchain, one of the things to point out is you need to consider, for example, if you deploy this as a permission blockchain, you're going to have to manage these resources on your own. But what about if you want to have like a payment gateway extension to a Bitcoin payment processor or some kind of exchange like Coinbase? Well, again, you need to determine how that's going to make sense. Now, as far as technology behind common blockchains, we'll talk about those technologies, but we need to understand that the technology is really no different than it's been 20 years ago. It's just the way the combination of technology comes together. So we're essentially talking about what? We're talking about encryption. We're talking about peer-to-peer networking. We're talking about contracts which are written in what? Programming language. Now, when is mining needed and when it is not? Well, again, it's more based on the requirement of, do we have nodes that are going to be shared, or do we not have nodes that are going to be shared? How are we going to pay for these resources? Now, if we're using proof of work, we need to have miners. On the other hand, if we're using other algorithms like a BFT approach or POET, we don't need to have miners. We'll talk about Byzantine fault tolerance. Now, on the exam, this is heavily tested, so I'm going to cover that here in a second, a little bit more deeper. Consensus, again, we need to have consensus reach. We need to realize how consensus is handled among the blockchains. Basically, for example, on the exam, you need to understand 3 blockchains. The blockchains that you'll be tested on will be as follows: Bitcoin, Ethereum, and Hyperledger. So we'll talk more about those blockchains and how consensus is handled. We're going to talk about hashing here in a second. I'm going to go to a demo and walk you through a few things. We'll then talk about, let's see, addresses, public keys, etc. That's part of our encryption discussion. Okay, smart contract. We know what a smart contract is. Basically, smart contracts are not smart, nor are they a contract. Now, can you have legal pros added like in Corda? Absolutely. But most blockchains are not able to deal with that. Security. Now, security is the million-dollar question here. What is security in blockchain? But basically on the exam, you're going to be tested on the common attack vectors, such as a 51% attack. You'll need to know the brief history of blockchain. You do need to know some dates. I'm going to recommend that you recommend to yourself that you memorize a couple dates. Now, the first is 2008 was when Bitcoin's white paper came out by Satoshi Nakamoto. Bitcoin deployed in 2009, and Ethereum and Hyperledger were deployed in what? 2016. So no 2008 and 2016, as well as 2009. Those are the dates you're going to see on the exam. Any questions so far? Okay. Programming language. We need to know what are the common programming languages. Go is very common to be used in Hyperledger. Solidity is used in Ethereum. Again, that's really the scope of what you'll need there. This is not a developer exam, so there's very limited requirements around that. And then how do you test and deploy? Okay. Now, I won't go through the rest, but taking the exam, of course, is fairly straightforward, not really hard. You do have to go to the testing center. It does take about an hour to take the exam. I don't think it took me that long, but you do have 90 minutes. You will know immediately when you pass the exam, or when you take the exam, when you submit, you will know you pass or fail. You need a 70. If you get a 70, you will get a certificate of certification. You will also have a token mailed to you, you put on your desk, and also a token that's going to be on the Ethereum blockchain that you could follow the Explorer to find as well. So pretty cool. Okay. Now, also, I will provide you a 30% discount on the exam if you like. The exam is $300. So again, just realize that it is a little bit pricey, $300. Now, the discount, when you add it to your cart, will bring, let's see here, will bring it down $90. So that's $210, that's $90 off. And the code is right there. I will put it in the chat as well so you have it. And let me get this. Just lost my place here. Okay. And so you have the discount code there. I'll paste in the chat here as well. And it is right here. Hold on one sec, chat. So the discount code is JH30ACS. That will provide you 30% off. Okay, let me go ahead and open up PDF here. Give me a second to pull it up. Let's go through the study guide, and I just want to walk through a couple areas here. I'll take another 20 minutes and answer any questions if needed. All right. And if there's any questions, feel free to pipe in the chat or raise your hand. I'm happy to answer that. Okay. Okay, there it is. A little bit slow tonight here. All right. And let me change my screen share because I think it's sharing my browser, not the PDF. Okay, let me do it again. Okay, so this is the official study guide, and also that discount code will take off a percentage as well. So it'll take off 30%, brings it down to about $21 if you did want to get that. Again, you don't need it. There's plenty of objectives that you can find online. So there's really, again, not much of a need to get it if you're already knowledgeable, but if you want to have it, you know, as concise as possible, this is the way to go. Okay, Now, let's talk about the history of blockchain. What I want to point out is when we talk about blockchain, you want to understand it from a human perspective. And there is essentially a Pacific island nation called the Yapese Nation, I believe. And they're on an island called the Yap Island. And they had stones called rise stones. But basically, and this is actually true, it's not something made up, but basically they use stones as a ledger to help keep track of who has what. And so that was like the first official form of a ledger. Now, ledgers are generally going to be centralized or decentralized. In the world of blockchain, we want to think of a ledger as decentralized in most cases. So we want to just think about that from that perspective. Now, what is a block? One of the things I want to point out is that a block is going to be typically utilized, especially like in the case of Bitcoin, can contain numerous transactions in a block. Well, that block is going to be appended to the blockchain, whatever that blockchain is, Ethereum, Hyperledger, or Bitcoin. Now, when you have a transaction and it's appended, we call a blockchain transaction being added to that string of blocks a chain. And that's where the word blockchain comes in. Now, when it comes to blockchain, one of the things to point out is, I was saying earlier, you do absolutely need to know Satoshi Nakamoto. Do make sure you know who the name Satoshi Nakamoto is and why he's important. You will absolutely see a question on Bitcoin. And also remember, we need to know the date that Bitcoin's white paper was released. That was what date? 2008. Bitcoin went actually live in January. And I will bring up the Blockchain Explorer and show you how to find the Genesis block. Now, when it comes to blockchain, it's a record-keeping system. And again, it's really important to understand that. When it comes to blockchain transactions, there's a few types of transactions that you'll want to know. The first is two or more parties exchanging value, typically monetary, or two or more parties that do not exchange money, but update some kind of notification or service. And lastly, the third one is lodging basically some kind of transaction that is not financial. So for example, when you get your certification with BTA, you will get a piece of paper with your certification token that will give you your address that is essentially your token on the blockchain. So this is a way that you can announce your basically credentials on the blockchain. So it's basically an announcement is the last one. So from a study perspective, I want to make sure that you study what a ledger is, what types of ledgers. So centralized ledgers are what? They're basically controlled by one party. Decentralized ledgers are not controlled by one party and they're distributed between the nodes. So know the difference between the ledgers. What is a block? Know what a block is. Understand different types of accounting. What is group consensus? I won't go through each of these. I'll leave that up to you to determine. Now, when it comes to how blockchains work, let's talk about a few things. Okay. Now, excuse me. Now, when it comes to blockchains, we want to make sure that we understand the importance of the benefits of blockchain. And the reality is that every organization and every person will have different blockchain benefits. It could be decentralization. It could be distribution of resources. It could be decentralization, but it could also be centralization as well, because blockchains could be centralized. Again, it depends on what is a benefit, transparency, etc. Now, cryptography. Let's go ahead and share my screen here. I need to do the hashing demo here. Okay. Okay, so I'm sharing my screen now. Give it a second to propagate. Now, what you want to do is go to this website, anders.com/blockchain. It is actually a very good website to start learning. And here is the link in the chat. Now, when we go to the blockchain demo site, be aware that there's several links up at the top that you could select. Select hash first. Now let's talk about what a hash is. A hash is basically a way to take an input and translate it to a specific output, essentially, in its simplest terms. So, for example, if I say here, hello blockchainers, you could see that the hash is a specific combination of letters and numbers. Now, it's 256 bits is essentially the usual hashing algorithm, and this is actually telling you right there, it's SHA 256. Now, you see that ends in 5A. Now, what happens if I change the input? What happens to the output? Again, you could see the 5D turn into 76. Then if I put it back to S, it's 5A. But if I take the S out, it goes to 76. So the lesson here is with every input, and with every input is a specific output. But when we change the input, the output changes as well. Essentially, the lesson here is to make sure that you know that a hash is going to provide a consistent output for a specific input. Now, let's talk about how this works in a blockchain. Now, the first thing is we want to understand how a block works. So the first block of any blockchain is usually called a genesis block. Let me put that in the chat for you. It's called a genesis block. Now, a genesis block is going to serve several purposes. The first is it's going to be the starting point for the blockchain. Essentially, it's the first block. And then the first block is then appended by what block? The second block that is written to the blockchain, and then the third and the fourth. And it allows us to not only track historical transactions, but also reference the starting point as well. Now, when it comes to a nonce, what is a nonce? Make sure you know what a nonce is. I'm going to put in the term here. So a nonce is nothing more than a random number. So when I change the nonce, then what happens? You see that the hash changes. Once again, that is a value added. So not only did we, and what happens if we change the block number? Do you see it changes? So instead of changing one variable in the hash here, we add some extra capabilities via essentially hashing, but also via adding a nonce, which is what? A random number. This will then create a hash. This is how the miners will start mining and solving problems. When we hit mine, you will then see some changes here. So you see that this had updated. Okay. Now let's go over here to the next page. Now, if you start at the left, you can see that this is block number 1. Block number 2 is here, and block number 3 is there. What happens if I change any one of these inputs? Well, guess what happens? It changes that block number, like when I change it from 1 to 2. Let's do that again. I just want to see it. So see, it's gray now. It was 2. And then I change it to 1, or I could change it to 22, whatever. And you can see what happens is that it changes the hash that is listed on the second, but the previous hash will not change. But again, just be aware when we update this that it's going to append to the first block. And then the third block is going to do what? It's going to append to the second block. Again, it's fairly straightforward to understand. On the exam, you'll need to define the behavior of a blockchain, and you need to understand that if you change the nonce or the block number or any of the data, what's going to change? Well, it'll be the hash, it'll be the nonce, the block, but the previous hash, for example, will not change, or the previous block number. Again, take some time to play with this. You'll get a question or two on the behavior of a blockchain. And do you understand the term nonce as well? You'll likely see that term again. Now, what I like to do here is let's bring up the Bitcoin Explorer. I want to talk about the Genesis block, and I just make sure you know what that is. And good thing they don't quiz you on the price of Bitcoin on the exam, because it is all over the map lately. But with that said, what we want to do is type in the Bitcoin Explorer. Now, there's several versions out there. I generally prefer the blockexplorer.com one generally. It's up to you to determine which one makes sense. Like this is the feel of this one. And then you could also go to this one here as well from blockchain.com. They're both good. It's just, it depends on how you like the format. As far as features and options, they pretty much have the same. I want to say like one has more ads than the other. It's up to you to determine which one makes sense. So this one here is pretty ad-free. So let's go over here and type 0. So basically, again, I selected, so let's say Bitcoin. And again, I could go over here to Bitcoin. You see the block height is 0. That's the main chain. This is the hash. For example, this is the next blocks. And look at the date on this. What was the date? It was 2009, January 3rd. So that was the Genesis block for the Bitcoin. So what is the Genesis block identified in most blockchains as? 0. It's the first block. Make sense? Any questions? Now down here, you could see the nonce as well as the Merkle tree. I'll also talk about what the Merkle tree is as well. And then you go over here, select and view the next block. So this is block number 1. And again, this is a blockchain explorer. This gives you visibility into the blockchain transactions. And this tells you more about the transactions and the amount of that transaction. Now, if I go back to the blockchain explorer main page here, and they move stuff around sometimes, so it's hard to keep track. But basically, I could also go over here and look at, for example, like the hash rate. Now, the hash rate is going to tell us what? This has given us basically a close to real-time estimate of how well the blockchain's performing. When you see, for example, the higher rates, that's telling you that there's, of course, higher activity. Now, if I select here on 2018, September 1st, you can see the hash rate is about 48,155,356. Okay, so again, you can see that that's the hash rate per second. So that's pretty good. And again, it's pretty steady over here. If I go to 1 year, you can see that it plots it out different. And then if you want to go all the time in history, you could see, for example, Bitcoin had very little activity until about January 2016, and then it really started picking up, and you could see the curve there. Now, the main thing to know about Bitcoin on the exam is, like I had pointed out, the date that Satoshi came out with the white paper. The date Bitcoin was released was 2009. That's really the main thing. Now, one more thing to point out is I want to make sure you know what a BIP is. So a Bitcoin BIP is called a Bitcoin Improvement Proposal. I always say, basically not correctly, but it's actually a BIP. Now, the BIP is going to attend to specific requirements. It could be to meet the needs of the developers or the environment. But basically, there's 3 types. You do want to know the 3 types of BIPs. You'll see one of these on the exam. Now, when it comes to the 3 major types, we have a standard track. Now, this is basically saying that there needs to be a change, and it's a recommendation for the change. Now, this needs consensus by the community. There's an informational BIP. I call this sort of like the newsletter. It's just saying, here's what's going on. And then a process BIP is a little different. This is going to be to propose a change in the process. This, again, is an important one. Usually when you see a BIP, this is going to be anything that could change the Bitcoin protocol substantially generally. And it could be also due to a security issue or something as well. So you could see some more information on this. So for example, segregated witness, BIP 91. You don't need to know any of that per se for the exam around Bitcoin, but you definitely want to know what a BIP is. It is basically a request to update or change something on the Bitcoin blockchain. All right, any questions on anything? Let's see the chat. Anything in there? Nothing there. Okay. All right, looks like we have 1 person on the call. Okay, great. Now, if there's anything you need, any questions, feel free to go ahead and chat it in. All right, now, as far as the Bitcoin Explorer, do you know how to find that? Just type in Bitcoin Explorer. The blockchain demo, the chat has a link there. Let's talk about Ethereum. Now, Ethereum, we want to know a few things about Ethereum. So the first thing that we want to know is, let me go to the project page first. So, 1 sec, they updated the page a little bit, so the colors are screwing me up. Okay, yeah, okay. So the first thing is to understand, for example, that you could have a wallet. And if you want to have a wallet, you could download the Ethereum wallet. Now, you could also use some other tools, for example, and I didn't actually, let me bring it up here, edit my extensions. Now, I like to use MetaMask as well for demos, but one of the things about MetaMask is that, and you do want to know what MetaMask is, you will see this on the exam, but you want to understand that this is a way that you could invoke a DApp, for example, on the Ethereum blockchain. It could be on a test net, and you don't need to download the full node. Like, for example, if I wanted to download a full node, like I could download my Litecoin Core wallet, and what'll happen is if I didn't boot up that wallet for a day or even a month or a year, it's going to take some time to download the full blockchain. So that's called a full node. Now, MetaMask is not a full node, and this is actually really beneficial for developers because you don't need to have the full node available. But again, you can go ahead and submit a contract, for example, like here's a few contract interactions that I had performed. See another one there. Transaction sent some Ether back and forth. And you can see that there is some activity as well. So MetaMask is actually a very useful tool. You will likely see a question on MetaMask and why you want to use it. The website for MetaMask, You don't need to know much more than what it is. I do just want to point out for you to look at metamask.io and know what it is. Basically, it's used as a bridge for your dApps and allows you to run in your browser. And when you run in your browser, you don't have to run what? A full node. Watch the little YouTube video here. It's actually pretty useful. And again, so MetaMask is one of those. Now, let's talk about the other areas that you'll see on the exam around Ethereum. Solidity. Now, Solidity is essentially a programming language. And again, you want to go over here and check out more about Solidity. Now, the main web page is here. Go over to Solidity, read about it, but the main thing I want to point out is that it is a language that is used for developing on the Ethereum virtual machine. Again, Solidity. Make sure you know what Solidity is, right? I'll type in the chat. Now, I'm going to have this recorded and available as well. You should get a link, so if you want to go back to the chat and review, that's fine as well. So do know what Solidity is. Take some time to look at that as well. Now, when it comes to other Solidity tools that are available, do take a look at Remix. So Remix is interesting because this is very similar to what Hyperledger has called Hyperledger Composer. And this allows you as a developer to play around with the Ethereum scripting capabilities, basically play around with the browser and the config. It's all online. And you're not developing locally, which again, you may not want to develop locally for whatever reason, but this is an on-ramp for you to test out your code. Now, you go over here and change settings and change versions and compile as well. If you have smart contracts, you can import them and validate against. So basically take a second, understand Solidity, and of course, some of the tools that go with it. And I think the only other one I want to just quickly mention is, I think I went by it. Oh, yeah, duh. Here it is. So this actually was discontinued. So you shouldn't see it on the exam, but that was something that was part of the objective. So just be aware. So that's called Ethereum Studio. That was an older IDE environment, but again, don't worry about that. The main things to worry about is MetaMask and what Solidity is. Let's see how we doing on time, and Remix as well. Now, when it comes to the EVM, we do want to know what the EVM is. So what we want to do is I'm going to give you a link to look at, because so the EVM is the Ethereum virtual machine, and it's actually pretty powerful. And I think it was on, give me a second. There's a couple really good blogs on it. This one here, I think it was Bitrates. Yeah, this is actually well written. It's very basic. And this is the level of knowledge that you just need to know for the exam. You don't need to know how to do much more than talk about why it's important and how it actually works at a high level. So the EVM needs to have something called gas. Now, I want to just type something in the chat here. Now, for you to get gas, for you to use mainnet, for example, you need to get Ethereum first. So one thing that's always a common point of confusion is that Ethereum is actually the platform. Now, to use the platform, we need to have, and I'm going to just put in the chat here for you, and just give me a sec. So Ethereum, to use the Ethereum platform, we need to have what? We need to purchase Ether. Now, Ether is used to do what? To essentially utilize the EVM. But to do that, we have to basically estimate costs, and we use a term in Ethereum to do that called gas. Gas is basically an estimate. And then gas is used for what? The EVM. This is for us to utilize the EVM. So on the exam, you'll likely, like I said, get 2 to 3 questions on Ethereum, and it'll be anything from gas to Ether to what the EVM is, but also development tools. I hope that is clear. Okay, so that's about all that I had for tonight. If there's any questions, do feel free to let me know. I don't believe the audio is enabled. Sorry about that, but feel free to chat in as well. This will be available shortly via email. You'll get a link, and I may post it online as well. Okay, let me see. Is there any questions? It looks like the audio is unmuted. If you did have a question, I'm happy to answer it. Okay, well, I wanted to thank you for joining, and we will have another one of these next week. Hopefully the time is good, and with that said, I do wish everyone a great night or morning or evening, wherever you may be. Take care. Have a great night.
Thank you. You too. Good
Yes,
night.
thank you. Yes. Thanks.